Okay guys, in this video lesson we're going to dive into Newton's second law and how that kind of works, right? So let's get going. Newton's second law. If you take a look at the words of his law, we got the acceleration of an object directly proportional to the net force acting on the object and inversely proportional to the mass of the object, okay? So that in itself kind of gives us what's going on here. If we take this statement and then rewrite it as an equation, we're saying basically that the acceleration of the object is proportional to the net force and inversely proportional to the mass. Okay, it's a very simple law, just F net equals ma, but it also has a lot of repercussions in terms of gravity, how we look at all kinds of movement. So it really is kind of this very powerful law that we're going to be using throughout the year. It's kind of a foundational thing because anytime we apply a force, if it's a net force and there's a mass there, we're going to accelerate something. Okay. Remember our units here. We got newtons, mass is in kilograms. This is not a weight. This is a mass now, and our acceleration here. Okay. And again, we've already kind of talked about this, but the most important equation in all of physics. All right. So the law itself is pretty straightforward. However, we should take a little concept check here and see what that means in terms of manipulating these numbers using F equals ma. All right. So what I'm going to do here is read you the question and then pause the video and go through and these 4 bullet points, kind of answer them yourself and see how you do on this. And then unpause the video and I'll go through each one and answer them so you know if you got them right or wrong. Okay. So here's our scenario. Object A has a mass of 20 kilograms. Object B has a mass of 40 kilograms. Okay. So if you look at this, A has half the mass of B. Okay. So use that scenario to answer these 4 questions and pause the video now. And then I'll come back here in a second and answer them for you. All right, so assuming you paused it, here we go. To accelerate them both at the same rate, how will the required force on A be compared to B? Well, since A is half the mass of B, okay, the required force will be half here. If they both undergo the same force, how does the acceleration on A compare to B? Well, in this case, because it's the same force, again, we have half the mass, the acceleration we're going to see on A will be twice that of B. How much force is needed to accelerate the object A at a rate of 2.5 meters per second? Okay, so now we know that our force is equal to mass times acceleration, so we're into our equation, and we want to know the force needed to accelerate it at 2.5 meters per second. Well, object A has a mass of 20 kilograms. We'll take that times a rate of 2.5 meters per second squared, and then we're going to get our force here. So 20 times 2.5, if I can do that one in your head, 50, all right? So the force we need here is 50 newtons of force in this case, okay, for this one. Next one, if you apply 25 newtons of force, how fast will object B accelerate? Okay, so now we know the force and we want to find the acceleration. So in this case, if we go F equals ma, but we know the force and we want to find acceleration. So I'm going to rearrange this and say the force divided by the mass will equal my acceleration. So our force is 25 newtons. The mass of object B now in this case is 40 kilograms. So our acceleration is 25 divided by 40. And I get an acceleration of 0.625. And you can label it in meters per second squared, but you can also label it in newtons per kilogram, because that is actually a valid label also for acceleration. Okay? So this one. Okay? So those are 2 examples of kind of how you can do this mathematically, solving for both of these things. All right? If we go on now and we have a little bit more complex of a problem, let's get work through this one. All right? So we have the Shelby Supercar Ultimate Aero TT. It can go from 0 to 60 miles per hour in 2.78 seconds. We have a mass, and we want the net force on. Okay? So we're looking for, of course, we want the force on this. We know the mass is 1247 kilograms. We don't know the acceleration though, so we're missing this piece of the puzzle. However, we are given it goes from rest, so our velocity initial is 0. Our velocity final is 26.8 meters per second, or 60 miles per hour. And we know the change in time that we are given here is 2.78 seconds. Okay, looks to me like this is we can pull this from a previous equation to solve this, which is pretty common with force problems, is having to use this one especially because we know how fast we got to, we know how long it took us, so we may not just give you the acceleration, you may actually have to solve for the acceleration first. Okay, if you recall, acceleration is equal to our change in velocity over a change in time. So our acceleration here is basically going to be our 26.8 minus 0 divided by 2.78. Okay, so 26.8 divided by 2.78, and I get a time of 9.64 seconds. Oh, sorry, meters per second squared. So our acceleration is 9.64 meters per second squared. So this thing can launch and accelerate you basically the same as if you were free in free fall. Okay, think about 9.64. That means that if you hit the gas on this car, it's going to feel like you're being launched the same way it would be if you jumped out of an airplane and free fell into the sky. Pretty much, okay? That's impressive. All right, now that we know these two things, we can take our acceleration, the 9.64, and just multiply that by the mass of the car, 1247, and we get, if we multiply these two together, a force of 12,021 newtons. So our final answer is such. Okay, right there. Okay, let's take a look on the screen, see if we did it right. Same idea, we found our acceleration, 9.64, took it times the mass, times that, and we got this. Because we were only given 3 significant figures, I did rewrite in scientific notation for that. All right, I'm going to stop the video here. In the next lesson, we're going to talk about what happens when we turn this vertical. Thank you.